Hello. Here is my attempt to set the record straight about the history of kinetic energy as it relates to the Clay experiments performed by Emilie du Chatelet and Willem Gravesande, I can't pronounce his name, and Leibniz. Did Leibniz do the experiments as well? Anyway, whoever did the Clay experiments originally deserved to have their work recreated reasonably accurately, not misinterpreted deliberately by the likes of Gary, so-called draft science, draft physics, so-called, who deliberately mischaracterizes, misconstrues just about every detail he possibly can about the Clay experiments, which he has no knowledge of whatsoever, has never made any attempt whatsoever to even find recreations of the experiments or to do them himself. You know, it would only cost about £25. Anyway, here's my attempt to correct the matter by doing the Clay experiments as properly as I possibly can. 3, 2, 1. Because no one else is doing it on the internet.
I mean, I have seen the Clay experiment.
Bullshit, Gary. You've not seen the experiment. If you had, you would have shown it to us. You haven't shown it to us. None of us have seen the experiment done properly. All we've seen is Hollywood reenactments just for the purpose of a film.
Into a pan of clay.
Dropping lead balls into clay.
I find it really cringy watching reenactments of real events by actors. I just find it kind of pathetic. How everybody has to be more good looking than they really were. And everybody's character is exaggerated and more smarmy. And the film industry never let the truth get in the way of a good story, do they? So they're not going to portray the experiment accurately.
Very imaginative.
Double the speed of the first ball on impact.
That's not the same thing as an actual experiment. Plus, you've probably seen it in your head. You've imagined it. You've not seen the experiment done properly, have you? You've never seen the experiment done properly. I mean real results, Gary, not ones made by a Hollywood prop department. The ball isn't supposed to go 4 times as deep. It's supposed to displace 4 times as much volume. That's what the experts say, not what Hollywood says.
Willem Gravesande conducted experiments which study the effects of gravity. He dropped a brass sphere from varying heights into a bed of soft clay. He measured the volume of the impact craters.
The volume, Gary, not the depth.
He measured the volume of the impact craters. What he found was astounding. The empirical data showed a non-linear relationship. The force of impact was increasing exponentially. Gravesande communicated his results to Emilie du Chatelet.
4 times the depth is a Hollywood myth, an internet myth, a draft science myth. It doesn't really happen. It doesn't make any sense anyway. The tiny bit you think you've learnt off what might as well be a cartoon. Might as well be Tom and Jerry. It might as well be The Simpsons. That's what you call having seen the experiment done. You've not seen the experiment done. You've seen a virtual cartoon of it. What you've actually seen is junk images like this. Wrong images.
So are you arguing that clay is a very good way of collecting energy?
Collecting it? What the hell are you on about? You can't use clay to collect energy, you idiot. You can use clay to measure it to a certain degree, but you can't collect it. Say, look, I've collected all this energy in this clay. Have it. You can use this to power your fridge. You really are a twit.
That clay doesn't, like, obviously deform all over the place?
What in the name of God are you talking about, Gary? You know how clay deforms. It can take an impression. It doesn't deform all over the place. It's not like jelly. It's been splattered against the wall. What is wrong with you that you've got to constantly misdescribe things just to get idiots on board on your side? There's no need. You can be honest and people will respect you for it.
So you don't even accept the argument that clay, how far something penetrates clay, is not a good way to measure energy.
Well, the reason I don't accept that argument is because I've tested it and found that it's perfectly adequate for this particular purpose, for this particular experiment. It's perfectly adequate for the purpose it's being used for in this instance.
Will you concede that point or not concede that point?
There's nothing to concede to because you haven't got any evidence. You haven't given any evidence. You've just given us something that you want us to agree with without giving us anything to base it upon. You haven't said, here's the data, I did the tests, and these are the results. I have. I'll give you some of the results now. Just a quick image because it'll take you a while to read it. I'll give you a quick flash of the image of all the information of my recent experiments. But you aren't going to give us any evidence, are you, Gary? Pillock. Now, to counter the lying moron that is Gary Draft Science, you'll see me doing it with 3 different grades of clay, 3 different consistencies of clay. We've got some that's as soft as butter, some that's as hard as chocolate, I suppose, and some that's just normal, and at different temperatures too, because that's something else that he's moaned about. It's such a tiny little factor. It doesn't alter the actual results of the experiment, as I show here. Oh, so again, enjoy. All I'm doing is dropping lead balls into clay.
Dropping lead balls into clay.
I hate how the people talk in this film. Everybody thinks they are Laurence Olivier.
To be or not to be.
But there's one extra thing I'm doing in this. I'm verifying that clay is a good measure of energy by dropping 4 times the mass from a quarter of the distance, which makes the same hole as quarter mass at 4 times the height, and that makes the same dent in the clay. We have to start off measuring the clay weight-wise and also measuring the temperature. So I'll try and skip over the boring bits and get to the nitty-gritty where dropping balls into it and making dents and then measuring the dents by filling the dents with milk and measuring it off a syringe. That way we can measure very accurately, much more accurately than if we get out a tape measure, and that's tricky. Okay, it's actually quite a fun experiment to do. I don't know why more people haven't done it. Well, in fact, nobody's done it, have they, as we can find on the internet. Okay, the classic original proof of kinetic energy, lead balls into clay experiments performed by Emilie du Chatelet et al. Redone by yours truly as evidence against the immoral lies of Gary Draft Science, so-called, wrongly describing their work, because he's jealous of a woman doing science. So I bought a massive lump of clay, I divided it into 3, I softened one up, I left one as it was, and I hardened the other. I measured the temperature of them at roughly 20 degrees, and I did some tests. A month later, when we had a particularly hot time in Great Britain, I tested the temperature again, 25.75 degrees thereabouts on all of them. And I redid the test, except I didn't bother redoing the medium one. I just did the soft one and the hard one. And so the test comprised dropping balls from 2 different heights, at 350 millimeters, and then 4 times that height, twice the velocity. That is not under contention. Everybody agrees with that, even Gary. So those lines represent the heights. Velocity 1 and twice the velocity. Now here are my pictorial efforts to represent, first of all, a 574 gram lead ball dropped from the highest at velocity 2. So it displaced 14 milliliters of clay in the soft clay, and it displaced 4 milliliters in the hard clay at 20 degrees roughly. It displaced 5.4 when it was 5 or 6 degrees warmer, and likewise the soft clay displaced another gram's worth, total 15 milliliters in the soft clay. Like I say, I didn't repeat the experiment in the medium clay, but the 574 gram ball dropped from the 1400 millimeter line, twice the velocity, that displaced 13 milliliters. Then, to check the validity of clay being a good measure of energy, I used Gary's only definition of 4 times the energy by using 4 times the mass, 4 times 574 grams. It actually came out 2.306 grams, so that penetrated the clay pretty much the same on average as the quarter mass dropped from 4 times the height, twice the velocity. They were pretty much equivalent, but if anything, the clay gave bias to low speed, high mass. So in the very soft clay, it displaced 21 milliliters. At a higher temperature, it displaced 20 milliliters. The medium clay, only done at 20 degrees C, the 2.3 kilogram displaced 15 milliliters, which is very close to the 13 milliliters that the quarter of that mass ball dropped from 4 times the height made. And so on and so forth. You can read these off yourself. You don't really need me to explain. It all becomes self-explanatory. So I'll just click through now. All the information is there. Right. Should we listen to some more of Gary's arguments against the clay experiment? Yeah, why not? It's a bit of fun, isn't it?
Because friction is variable. The faster you go, the less friction you'll encounter.
Pure conjecture on his part. He has no evidence to support this. And I'm quite certain that, well, the clay experiments that I've done show the exact opposite. The clay gives preference to slow-moving objects, almost like a non-Newtonian fluid. Aeroplane designers have difficulty making things go faster and faster because they encounter more and more friction the faster they go, don't they? Not less and less. That's just ludicrous. That just shows how thick Gary is. The faster they go, the harder it is to go faster.
The faster you go, more likely it is you're just tearing atoms. Lots of things change. The thermodynamics of every substance changes as you.
I love how he throws all the right words in, all the technical words, to make it sound to idiots like he knows what he's talking about. He hasn't got a clue what he's talking about.
Like breaking a piece of wood, the karate guys, by increasing the velocity, they decrease the amount of energy they have to use to break the wood.
Completely missing the point that increasing the velocity, the energy is squared, isn't it? Not in his book. No. The increased velocity, the less energy they need. He just talks utter crap.
The fibers they don't have time to react to the energy, therefore they can't absorb it and they snap.
He's got a good imagination, I'll say that for him. He's got a good imagination for things that he wants to convince himself of and convince other people of.
Instead of bending. And so if you can cause things to snap instead of bending, you can make something move a lot faster or a lot further through it.
And I love how all the time he's talking his crap, he keeps dotting and adding little dots and little arrows that are meaningless and underlining things and circling things. And so his drawing ends up just an endless collection of scribble that is supposed to mean something, and it means nothing. It's just his doodling, him trying to convince himself that he knows what he's talking about. The stuff he draws rarely means anything. If you show those drawings to anyone and ask them to explain what's this drawing probably mean, at least hint to them what the subject matter is, a qualified physicist or whatever, they're just saying it could be bloody anything, couldn't it? His drawings are meaningless, just as his words are.
Again, now, is this really, really complex physics I'm explaining?
It isn't physics, Gary. Do you mean is it complex physics? It's not physics. It's just you making up crap. It's not physics, you moron. It's just you guessing how things work. That's not physics.
This is a detail that only the most brilliant minds in the history of mankind could figure out. That.
And I like how you butter yourself up, how you flatter yourself by suggesting that it takes any intelligence to come up with a load of old made-up crap. Your theories are just a load of old made-up crap. They have no basis in fact whatsoever. They have no evidence whatsoever.
Some substances have a bias against velocity.
Very soft clay, for instance. That's what we found out. It's like a non-Newtonian fluid. It has a bias against velocity, if anything.
Or a bias for velocity.
Like what? I know you're thinking clay does, but it doesn't. So like what? What does have a bias towards velocity? Again, you're just making up crap. Making wild guesses that suit your purpose.
That the faster you go, the further you go.
Show us this happening in any material whatsoever. Show us this happening. I've showed you the opposite happening. I've documented it accurately. Now you show us what you claim happens. It's not up to me to show what you claim happens. I've shown what you claim happens doesn't happen. Now it's up to you to show me that I'm wrong. Not just talk about it, you moron.
Versus, much further, that the friction isn't applied evenly to all objects.
That doesn't mean anything.
Because the faster objects incur less friction.
Show us your evidence. You haven't got any. It's just you making shit up again.
You could see it even on a road. Like say if I had a road with just a couple little tiny bumps in it.
In other words, a road. Show me a road that doesn't have bumps in it.
You could argue that a fast thing hits one bump, goes airborne, and just flies over the rest of the...
Oh, so cars are little aeroplanes, trucks are little aeroplanes. But while they're losing contact with the road, they cannot be accelerating, can they? Idiot.
Friction. I mean, simple little arguments.
For simple little people.
Simple little arguments.
For simple little people.
But the point is that she could show that she could drop two objects, one from 4 times as high. I should make this. Okay, and she could show this dramatic result that the one dropped from the higher point, went much deeper into the clay.
No, to be more accurate, displaced more volume. It's kind of similar, but it's not quite the same, and it's important to make that distinction.
and twice the velocity and the same mass, you could argue it has twice the energy.
But, Gary, if you were correct, how come, by your definition of 4 times that energy, 4 times the mass, that is 4 times the mass of that, how come that 4 times mass makes exactly the same dent in the clay as that does from 4 times higher? So clay is a good measure of energy. Do you honestly not think, Gary, that Emilie du Chatelet, conversing with all those great mathematicians of the day, plus Willem Gravesande himself, Paulini, Bernoulli, and Leibniz, do you honestly think it never crossed any of these people's minds to test whether clay was a good measure of energy using that method of comparing that at 4 times the height of that 4 times the mass? Do you honestly not think that they tried that? Do you honestly think that they didn't try that most obvious test? Why hasn't it occurred to you to try that? Because you've no interest in trying it. Because you have no interest in checking whether clay is a good measure of the energy. And it is. You were wrong. Get used to it. So we either go for 4 times higher or 4 times the mass, and they both make the same whole. So clay is a good measure of energy. We either say 4 times higher or 4 times the mass, and they're both 4 times the energy. We either say 4 times higher or 4 times the mass, and they both make 4 times the energy. Twice the velocity, or the same velocity but 4 times the mass. They both make the same dent in the clay, Gary. You need to get that through your thick skull. Clay is quite an acceptable measure of energy for the purposes we need it for here. We're not measuring it to 1% or 2%. We only need to check whether that is creating 4 times the energy. And that makes the same bloody hole, so we don't need to worry about whether clay is super accurate. It's good enough for the task, idiot. It's good enough for the task. It's not 50% out. It's not 100% out. It's not even 10% out. It might be about 2 or 3% out. Look at my figures. Do the test yourself. Measure as accurately as I have. Make the effort. Make the effort. Make the effort. You bone idle fucker. You bone idle bastard. You are the one person who ought to be interested in doing this, because you of all people have more interest in this subject than anyone else. The clay experiments. So it's in your interest to debunk it by actually doing it and showing that that doesn't depress the same amount as that 4 times higher. It does, but that's your problem. And yet you don't do it, do you? Why not? Because you're a stupid idiot, that's why. In simple terms.
And you'll know that because you'll have an impact and blah, 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 blah. But
what the hell does that mean, Gary?
What kind of talk is that?
And you'll know that because you'll have an impact and blah, 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 blah. But
you'll know this because it'll have an impact and blah, 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 blah. What? That doesn't make any sense at all. The fact that it makes an impact isn't news to anybody. We know it's going to make an impact. It's how big an impact, how great a volume it displaces. And what's all this blah, 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 blah supposed to mean? We're supposed to assume that you know something just by saying blah, 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 blah. I might as well say, well, heart surgery is easy. You just open up the chest and blah, 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 blah. Brain surgery is easy. You just open up the head and blah, 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 blah. That's your science, isn't it? Blah, 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 blah. Idiot.
And you'll know that because you'll have an impact and blah, 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 Doing it with clay, you know this could have a huge bias for velocity.
Could, but it doesn't. It turns out to actually have a very slight bias against velocity.
MV. Again, she was defending MV. They would say to you the answer is 100 joules.
But we could just as easily have been saying 50 Leibnizes, couldn't we? There's nothing special about joule. You could have made it a Leibniz instead, and it would have been a different quantity. Same difference.
And by your modern formula, no, the answer is 50 joules.
Or 50 Leibnizes, like I've just said. We don't have to define energy as joules. We don't have to define power as watts. You don't have to measure bananas in pounds or kilograms. You can then measure them in whatever you want. There's nothing special about a joule other than it was decided to use that as a unit of measurement. You can use other units of measurement. And if you use Leibniz's instead, we wouldn't have had to have the half in front of the formula. Dickhead.
I mean, that's how far off it is.
You're just exposing your misunderstanding of how measurement works. Idiot.
It's not close at all.
Because it depends what unit of measurement you're using. Idiot. If a Newton was defined in pounds instead of kilograms, then wouldn't we have to multiply the mv squared by 1.1? Off the top of my head, that's about it, I think. Instead of halving it, we would have to multiply it by 1.1 because there are 2.2 pounds in a kilogram, aren't there? I think. Yeah.
To being the truth. And yet they were all certain they proved it.
You're an absolute idiot if you think that you've got a point by talking about the half. There's something wrong with you.
They're all certain it was well evidenced.
Because it is well evidenced. Just choose different units, you'll get a different answer. Pillock.
Alright, well anyway, so in the 1800s, they invented the word energy.
Oh, let's leave it there with them disputing the word energy. The 4 times heavier one dropped from 350. Oh. Now I would like to drop this little one. Cover those up. Alright, so perhaps I should write down which one was which so I don't forget. Well, that one's obvious. So this one is the first one, so I'll say number 1. And that was from 1.4 meters. And this was number 2 from 350 millimeters. And that was also from 350 millimeters. That was number 3. So now I need to take this clay away and just let you have a closer look at it. Obviously the little indentation at the top, that's made by that at the 350 millimeter mark. I mean dropped from the 350 millimeter mark. That's just over a foot, okay. So that's made a little indentation. Now the theory is that when we drop that from 4 times higher, that's 4 times the energy, twice the velocity but 4 times the energy, and that made the hole on the left. That's been dropped from 1.4 meters, 4 times the height, okay? To the right of that is where that was dropped from the 350 millimeter mark. This is 4 times the weight of that. 4 times the weight of that. Even by Gary's standards, that is 4 times the energy of that. But it's been dropped from the same height as that, and yet it's made the same hole, the same dent as that from 4 times the height. So we know that clay is a reliable measure of energy, really. Without being silly about it, without being pedantic about it, without being an arsehole like Gary, we know that clay is a decent measure of energy. Now, this is one of the early ones I did before it even crossed my mind to bother listening to Gary's nonsense claims about doing it with different consistencies of clay. So this is just using the clay normally as it came out of the bag, just normal clay. Perfectly adequate. I'm a bit annoyed that the 2 mass fell over. 4 mass, not 2 mass. The problem with this is it's top heavy, so it keeps landing like that on a funny angle and not making as big a hole as it should, which is why it only displaces 11 millilitres of fluid. It should be more like 12, really. Cover that up, and I try dropping this again. Annoying the kid's falling out. I'm going to have another go. I just want a clean one where it stays in the bloody hole it dropped in, you know what I mean? It's just very difficult to drop it exactly where you want it. I'm a bit high now, I'll have to drop it from a bit lower. I've got to knock off 18 millimeters, so instead of dropping it there, I've got to drop it from just under that arrow. Well, 18 millimeters below that arrow. Here we go. The reason I end up doing this entire experiment again is because I run out of room to try and get a decent drop of this. It keeps either landing too near the edge or toppling over, but eventually on the next run I think it is. But when I do this experiment again, I eventually get it so it lands perfectly straight and stays in the hole, which is all I wanted. Why is everything such hard work? See what that's like. Tilt it up so you can have a look at it. I've put 4 but X against it because it was the wrong height. And then this was 5 from 350. Okay, so let me just tilt the clay up so you can see it. Right, I might have a go at recording on 2 cameras at once here. I did record on 2 cameras at once, but for some reason I can't find the footage of the other camera. Go 1, go 2, and go 3. Those are the afterthoughts ones. I'm going to put some milk in a syringe. This will please the vegans, won't it? I filled it with 10 millilitres. Let's do number 1 first. Okay. Well, it'll hold a little bit more, but I'll put 10 millilitres in number 2 now. That was the one that was dropped from 1.4 metres, and it was the small weight. 10 millilitres again. Ooh, not quite level. Hang on a sec, I'll leave that little tiny bit left in it, but it's not quite level. It's just needs coming my way a bit. I think I over put too much cardboard under this side. Let me just tear a bit of cardboard off and stick it under the other side. I can see it's tilting that way. Not up to that edge now. Well, you don't know until you try these things, do you? What the problems are. I think I put too much cardboard under this side, didn't I? That was the problem. When I tried to. Oh, anyway, they're near enough the same anyway, aren't they? They're both holding about 10 mil. But put that a bit more in now, can't I? Right, it's not overflowing, is it? So that can hold a little bit more though. 10 millilitres in that, 10 in that so far. Let's see how many more this can take. I'll fill that up to 10 again. So then I'll see how much more this can fill. Oh, there. And that was, it's on the 8.5 mark, so it left. So we'll put another 1.5 millilitres in there. So I'll write that. That's 11.5 millilitres. 11.5. And this one so far is, load this back up to 10. Back up to 10 again. So I want to see at what point this starts looking dodgy. There. Oh yes, I've gone over there. But that did an extra 8.5 left. So if 8.5 is left, then that 2 is holding 11.5, isn't it? 10. Yeah, it's 8.5. I'm going to say 11 because this one's overflowing a tad more than that one was. But then again, I'll say 11 on that. Now we need to do this one. This is the one that should be a quarter of that. It should be about 3, shouldn't it? We're expecting about just a tad under 3, I would have thought. Okay, so I've got 10 millilitres in here. Well, it's not gonna. So I've gone all quiet. I'm concentrating. It's overflowing now. On number 7, so that's 10. 1, 2, 3. Oh, yeah, so it's done 3. Yeah, so it's done 3 millilitres. So the 11 is taking into account the slight overflow. Right, so 10 millilitres again. 10 millilitres again. The first one, which was, only 18 millimetres. It was only 18 millimetres too high. Because I forgot that I'd put a sheet of polystyrene to protect the other holes underneath the guide board. So I'm dropping it from 18 millimetres too high. It's not a big difference, is it? But I still did the entire experiment again from scratch after this. I'll do that as a separate video, otherwise it's too much at once. And that easy takes 10 millilitres. That needs levelling up again, doesn't it? Hey, hang on, let me put some cardboard under this side because it's not level. Sorry folks. Just trying to level it up a bit. Because you can see it's not full at all, this one. Got 10 in so far. Load up to 10 again. See how many more this can take. Oh, there we go, it's overflowing now. Just over 7 left. So 1, 2, 2 3/4, 2.5, obviously, because it's leaking now. But it's not full that side though, that's the point. It's not filled to that side. 1, 2, I'll call it 2.5, make it, what's that make it? So it's 12.5 there then, isn't it? So yeah, so this one would be 12.5. Take into account that, you know, if you knock another half off so it isn't overflowing. Oh, camera's switched off. This camera's complaining, or maybe it's just run out of battery time. I think this one's run out of battery time, so I'll finish now. Okay, thank you for watching.